So the third type of rock is metamorphic rock. And as the name metamorphism suggests, this is rock whose structure has been changed by heating, by pressure in the interior of the Earth, and then returned to the Earth's surface by dynamic processes. What do we mean by dynamic processes? Some kind of mountain building or uplift that has taken this rock from deep below and brought it back up to the surface. With metamorphic rocks, we characterize them by what we call the grade of metamorphism. Is the rock only slightly modified by heating and pressure, or is it deeply modified by heating and pressure? Perhaps even so that it partially starts to melt back to the molten state. So when we look at the samples of metamorphic rocks, keep this in mind. We're going to go through a series of metamorphic rocks from lightly metamorphosed, or what we call low metamorphic grade, to highly metamorphosed rocks. These are rocks that have undergone extreme changes due to heat and pressure. So what we see here is a suite of metamorphic rocks from low grade to high grade. And remember that as we go to increasing grade, we go to increasing metamorphism, increasing changes in the rock due to increasing heat and pressure. So these rocks maybe started out from a mudstone or a siltstone, and with a little bit of heat and pressure, the clay minerals in that mudstone achieved a preferred orientation and hardened together to form this slate. This slate is the same kind of material that people used to use as chalkboards. They could write on it because of the fine planes here where this rock just flakes apart into sheets. So that's the slate, the lowest grade metamorphic rock. With increasing heat and pressure, we can change the crystalline structure of that slate into something where we have fine-grained mica minerals being formed within here. And so you can't see them from the naked eye, but this phyllite has fine-grained mica in here that has a preferred orientation. And you can see some of the orientation of this structure, and this one here with a little bit more iron has a preferred structure. It's got some metamorphism that has gone beyond the slate. These next two samples here represent schists. This is where we start to see the mica crystals in a visible way. So here we have relatively small mica crystals. It just gives a little sheen to the rock surface. And in this case, it's even got some deformation. You can see the folds here formed as a result of the bending of these rocks during the metamorphism. This schist, on the other hand, is much higher grade. You can see much larger crystals, more specular reflection rather than just a sheen. And these garnet crystals, again, a symbol of a signal of very high grade metamorphism within this schist. Then the next sample here is a gneiss. Again, we can tell that this is a gneiss because of the large crystals. So these crystals have undergone extreme changes and almost to the point of melting. You might confuse this with an igneous rock, except it's got these preferred orientations of the minerals within there, again indicating the extreme heat and pressure that this rock has undergone. And when you look at this rock here, this is a migmatite, and in this migmatite there's been melting of this rock. There's been so much heat and pressure applied to this that it's been melted and is recrystallized almost as a new rock. Not quite an igneous rock, but pretty close to it. So this is the whole suite then of metamorphic rocks given kind of a parent mudstone or siltstone. We've got the slate, the low-grade end of the metamorphic rocks through the phyllites and the schists here of varying degrees of metamorphism to the gneiss, and the point where we even start to remelt this rock almost to the point of being an igneous rock, but the migmatite being the highest grade metamorphic rock within this particular suite.